Hello guys, our today's lesson will be computation of determinants. Okay, suppose that we have an n by n square matrix A, this one, A11, A1J, A1N, AI1, AIJ, AIN, AN1, ANJ, and ANN. This is the matrix of A. If we remove the i's row and j's column, then our new matrix will be this: A11, A1, J minus 1, A1, J plus 1, and A1, A, I minus 1, 1, A, I minus 1, J minus 1, A, I minus 1, J plus 1, and A, I minus 1n. Then here it will be A, I plus 1, 1, A, I plus 1, J minus 1, A, I plus 1, J plus 1, and A, I plus 1, N. Then here will be A, N1, A, N, J minus 1, then A, N, J plus 1, and A, N, N. You see here, in order to get this matrix, we have removed i's row and j's column. And for this matrix, we use this notation: A, I, J. This. Okay, look at here. We denote Aij the submatrix obtained by removing the i's row and j's column of A. And the determinant of Aij is called the minor of order m-1 of A. The number of Cij is called the cofactor of A with respect to coefficient Aij. And here I and j show the places of rows and columns respectively. Okay. Let's look at this example. Suppose A is this one. Calculate A11, C11, A32, C32. Okay, let's calculate A11. A11 will be, we remove the first row and first column. It will be 2, 1, 1, 1. C11 will be minus 1 to the power of 1 plus 1 times the determinant of A11 is equal to the determinant of 2, 1, 1, 1 is 2 minus 1 is 1. That's it. let's find this submatrix. A 3 2 is, we remove the third row and second column. It will be the matrix of 1 3 4 1. Then C3 2 will be minus 1 to the power of 3 plus 2 times the determinant of A3 2 is, this is minus 1, determinant of 1 3 4 1 is equal to minus 1 minus 12 is 11. That's all. In order to calculate the determinants, we will use expansion along rows and columns. Okay, we have an important theorem called expansion along a row and column. Suppose that we have an n by n square matrix A. Then the determinant of A can be evaluated by means of two formulas. This formula you see here, Cij, is the cofactor of A with respect to Aij, and from here you see ith row is fixed. Because of this, it's called the formula of expansion along ith row. In order to calculate the determinant of A, we can use this formula as well. From this sum, you see the j's column is fixed. Because of this, this formula is called the formula of expansion along the j's column. Exercise. Calculate the determinant of A. In order to calculate the determinant of A, we will use the expansion formula for the column. We will fix the second column, because here there are two zeros. Then the determinant of A will be 0 times cofactor C12 plus 2 times the cofactor C22 plus 3 times the cofactor C32 plus 0 times C42. It will be, this one and this one will be 0. From here it will be 2 times C22 plus 3 times C32 is equal to 2 times minus 1 to the power of 2 plus 2 times, we remove this row, the determinant of 4, 3, 1, 0, 1, minus 1, 1, 2, 3, plus 3 times minus 1 to the power of 3 plus 2 times in order to get this cofactor, we remove the second column and third row. This. It will be the determinant of 4, 1, 3, 4, 1, 0, 1, 2, 3. This is equal to, here in order to calculate the determinant of 3 times 3 matrices, you can use the Saros rule or expansion formula. It's up to you. If you calculate this result, it will be 83. That's all. Remark. The expansion along a row or a column allows to evaluate the determinant of an n times n matrix by means of n times n minus 1 times n minus 1 determinants. Thus, the expansion along a row or a column becomes tedious when n is large. In general, when n is large, we apply this method only if the matrix has plenty of zeros. And as you know, in order to get plenty of zeros in determinants, we must use some elementary operations along the rows or columns. That's it. Inverse of a matrix. Suppose that we have an n by n square matrix A, then this matrix is called comatrix or adjugate matrix of A. And for the adjugate matrix of A, we use this notation, com A. Let's look at this theorem. Suppose A is an n by n square matrix, and it's also invertible. That is, the determinant is different from 0. And C is the comatrix of A. Then the inverse of A is equal to 1 over determinant of A times the transpose of comatrix. Let's look at an exercise. Determine the inverse of A and B. Look at A. As you know, in order to find the inverse of A, we will use this expression. The inverse of A is equal to 1 over determinant of A times the transpose of the cofactor of A. This. So we first calculate the determinant of A is equal to 1, 1, 0, 0, 1, 1, 1, 0, 1. This. Here I will use the expansion formula for the first row. Then we fix the first row, and then we remove the first row and first column. It will be 1 times minus 1 to the power of 1 plus 1 times the determinant of 1, 1, 0, 1. 1, 1, 0, 1. Plus, we remove the first row and second column. It will be 1 times minus 1 to the power of 1 plus 2 times the determinant of 0, 1, 1, 1. 0, 1, 1, 1. Plus, we remove the first row and last column. It will be 0 times minus 1 to the power of 1 plus 3 times the determinant of 0, 1, 1, 0. 0, 1, 1, 0. From here, this part will be 1. This is also 1. And this one is 0. Is 2, which is different from 0. Because of this, this matrix is invertible. Then we calculate the adjoint matrix of A. Is equal to C11, C12, C13, C21, C22, C23, C31, C32, and C33. This. Let's first calculate the values of the cofactors. C11 will be minus 1 to the power of, we remove the first row and first column, 1 plus 1 times the determinant of 1, 1, 0, 1 is equal to 1. C12 will be minus 1 to the power of 1 plus 2. We remove the first row and second column. 0, 1, 1, 1 is equal to 1. Using the same procedure, C13 will be minus 1, C21 will be minus 1, C22 will be 1, C23 will be 1, C31 will be 1, C32 will be minus 1, C33 will be 1. Then from here, the adjoint matrix of A will be this. One, one, minus one, minus one, 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 minus one, one. This. Then we find the transpose of C. The transpose of C will be this. 1, 1, minus 1, minus 1, 1, 1, 1, minus 1, and 1. This one. From here, the inverse of A will be 1 over 2 times the matrix of 1, minus 1, 1, 1, 1, minus 1, minus 1, 1, and 1. This. That's all. I believe using the same procedure you can determine the inverse of B by yourself. Okay. That's all, students. See you next lesson.